Welcome to Evolkai, a community for machine learning enthusiasts. Now, today we will be learning about logistic regression, a machine learning model. So, uh, from first appearance of this graph, you would find that you would say, or this thing would come to your mind that SVM and logistic regression are same. But it is not like that. Logistic regression is a statistical analysis data that truly works on the basis of probability of finding the data. Now, let us just take an example of SVM graph. In the last video, in the SVM video, we saw that um, the data were completely separated into two sections. Like you could see the data on the different parts on the different side of the line. But in the case of logistic regression, where there is a cluster of data, and this model tries to get a line using the logistic function which it creates by itself, which separates the data into two parts. Now like for the SVM, data being on the left or right doesn't matter. The closer the data is to the line matters. So the closer the data is to the line, the probability is given as 1, and the farther the data, the probability is given as 0. So more closer the data to the line will be more accurate. Now we will see the practical implementation. Uh, so we have worked on iris dataset, and further explanation of the slides, I will show you the practical implementation too. Now, simply like in the previous video, we will import pandas library and use the read CSV function of it, and read the iris data. Data.info will give us all the information related to the dataset, like what are the columns and what are the data types. Now, we will simply define features and prediction class. Today, I will show you one another method to do the same step. But for the sake of slide teaching, I'll just go with this one. So here we will select the features for like sepal length, sepal width, petal length, and petal width, and the prediction classes will be species. Now the X will have all the inputs that a user will give, and Y will have the output. Now, based on this sepal length, sepal width, petal length, and petal width, our machine learning model will try to generate the species. Now, from train test split, this is a module present in this sklearn.model selection library, where it is used to separate the data into X train, X test, Y train, and Y test. Now this test size divides the data into four categories, where the testing size is 0.30, that is 30%. Now the rest 70% will be our training part. That is as I have told in my earlier videos, that training part is the most crucial part, and the more the training part, the more accurate your data will be. Now simply we'll print the training shape, testing shape, to get the training and testing shape, because we will get what we did from this we will get the data what we did what the function did train test split. So we will be able to see what this train test split did. Now we will import the logistic regression function from sklearn.linear model, and we will fit x train and y train data in that classifier. Now we will predict the data from the X test and take it into the Y prediction data. Now Y pred will contain all the prediction data that has been taken with the input values of X test. Now, after importing metrics from sklearn, we will get accuracy score. Now this accuracy score will tell us the accuracy of our data. Like YPRED has all the data we have from the X test, and Y test already has all the data from X test. Now, if when the Y test and YPRED values will match, the accuracy score will increase, and thus it will print the accuracy. Now we have come to our VS Code. So firstly, I'll run I'll run this model on Iris dataset. Then I'll show you the same model on the PIMA dataset that totally has all numerical values, while in the case of Iris dataset, it has string values. That is, the name of the species are in string. So let me just run this. Let me just run all, because it is same. If you have seen my previous videos, then you would be knowing the code. So let me just show you. So the accuracy is 93. Now using the logistic using now I'll use the same uh, model on Prima dataset. Now let me just change the file name. Now I'll run first cell, second cell, third cell. Now you can see that in the data info, these are all the column names. You can see pregnancies, glucose, blood pressure, skin thickness, insulin, and all are given here. So here we can say that in pregnancies there are total 768 entries, and there is no cell which has a null value. That is, every cell has non-null values. That is, at least some values is there. And the data type for pregnancy, glucose, blood pressure, skin thickness, and BMI, insulin is int 64. That no decimal values are used. For BMI, diabetes, pedigree function, float 64 is used. That is, decimal values are used. Now, for overall report, there is two float 64 values and seven int 64 values. Okay, now this will change, so we will just comment it out, and I'll show you a new way of doing it. Now, since we have our file loaded to data model, to this data variable, so for x we just do not need, we need let me just remove this. We need all this for x function, for x variable we need all this, and we do not need outcome. So we'll just drop the outcome here. uh, Column is equal to outcome, and for the y we will take we'll remove this values part, and in instead of prediction class I'll write outcome there. So it will take the respective values of these columns. Now I'll run the cell. It gave no error. Now since the test size is divided into 30%, please check the shape of x test, x train, y test, and y train. Now see, X test, X train, Y test, Y train has changed. Now you can say that you can see that X test has only the X values, and X train also has see, the Y part. The Y part only has the X axis part, and the rest has the X and Y both. So if you have this, then your this error won't come. This error suggests that the data that Y should always have 1D array. 1D array suggests that only x or only y should be there, not both shouldn't be there. Now I'll just run this cell. Okay, so it gave me a warning that increase the number of max iteration on the scale. On the scale the data as shown in this, so it is asking me to increase the max iteration limit. So I'll just go into the logistic regression part. I'll just increase the max iteration limit to, let me just, it is a hit and trial method, so you have to check for 100 iterations is it removing this. So still it is showing. Let me just do it for 200. Okay, so no no warnings now. Now I'll just print the accuracy to check how accurate is our model. So it is 74% accurate. The PIMA dataset is 74% accurate on logistic regression. So this was all the coding part. Now back to the slides. So for this model, our accuracy has come out of like 0.78. Okay, so what we have gathered from all this is that logistic regression is a powerful statistical tool, and it works very well with the data set that only has numerical values. Now in the further coming videos, we will see how the string data is converted to numerical data. But as for this data that that we have shown you today, that is the PIMA diabetes data set, which has all the numerical data. These type of model This type of model is very good for it, because it has it has all numerical data, and making a logistic function is very easy for the model. Okay, so thank you for your patient listening, and happy learning.